Hey everyone, and welcome. Today, we're going to pull back the curtain on one of the most fascinating fields out there, AI-enabled robotics. So, let's just dive right in.
Think about it. From the incredible precision needed in an operating room, to the dangerous, dirty work of checking industrial pipelines, and even offering a helping hand in our own homes, these smart machines are already changing our world in some pretty major ways.
And that really is the big question, isn't it? How can the same basic technology power a surgical tool and a robot in a warehouse and a guide for someone who can't see? Well, it turns out they all share a surprisingly simple and common design. To really get it, we've got to look at their basic anatomy. You can think of it like a universal blueprint that fits just about every single AI robot out there.
Yeah, it all boils down to just three core parts. No matter how complicated a robot seems, you can always find its body, its senses, and its brain. So let's break each of those down.
So first up, you've got the body. This is the hardware, the part of the robot that actually gets its hands dirty and interacts with the physical world. It might be a super flexible robotic arm with 7 different joints, or the wheels on an autonomous car, or even those tiny little tools at the very end of a surgical arm. Those are called end effectors. Okay, next up, the senses. A robot is totally blind without data. Its senses could be anything from high-def cameras that give it vision to LiDAR systems that shoot out lasers to build 3D maps of a room, or even really cool haptic sensors that give a surgical robot a sense of touch through vibrations and resistance.
And finally, we get to the most important part, the brain. This is where the real magic happens, the AI in AI robotics. It's the powerful software that takes in all that data from the senses, figures out what it all means, and then tells the body what to do next. We're talking about complex neural networks and image recognition models that can spot a single bad apple on a conveyor belt moving at lightning speed.
This is where it all clicks into place. You can see how the body, say a robotic arm, uses its senses, like 3D cameras, to see the world. That visual information gets sent to the brain, which runs an image recognition model, makes a quick decision, and then tells the arm what to do. Body, senses, brain. It's this constant, intelligent feedback loop.
All right, so now that we've got the blueprint down, let's see how it works in one of the most intense environments you can possibly imagine, the modern operating room.
This just shows what a huge leap forward we're talking about. A system like the Da Vinci robot uses its mechanical body to totally steady a surgeon's hands, filtering out any tiny tremors. Its senses give the surgeon this amazing, immersive 3D high-def view inside the patient, and its brain provides haptic feedback. That means the surgeon can actually feel the tissue they're working on through the controls. It's incredible. Now here's a really important point. This isn't about replacing surgeons, it's about making them even better. We can see how this works on this ladder of autonomy. Right now, most systems are supervised. They're basically a high-tech tool. But here's the thing. Full autonomy isn't even the goal for a lot of procedures. The real revolution is happening in that middle step, collaboration. That's where the steady hand of the machine and the expert judgment of the human create something better than either one could do alone.
And hey, this isn't some far-off sci-fi future. This is happening today. You've got the Da Vinci system for all sorts of complex surgeries, the ARTASIX, which can autonomously perform parts of a hair transplant, and systems like Mako and Rosa that are bringing unbelievable precision to knee and hip replacements.
It's truly an amazing leap for medicine, but surgery is just scratching the surface. So you gotta wonder, where else is this body, senses, brain blueprint popping up?
So, let's step out of the operating room and onto the factory floor, the warehouse, and even the farm. This is the rise of the automated workforce. You know, the same exact principles, a physical body, advanced senses, and an AI brain are being put to work everywhere. And they're quietly starting a revolution in how we make stuff, how we move stuff, and even how we grow our food. The sheer variety here is just mind-boggling. The same basic design can power a robot that inspects a dangerous gas pipeline, a job that's way too risky for a person, and it can also run the entire sorting system of a giant warehouse. And then you've got specialized bots like Robotic checking on crops, and even robots designed to just pull trash out of our rivers. It's wild. And maybe the biggest reason this is all taking off? These systems can just work. 24 hours a day, 7 days a week. They don't need a break. That means a huge, huge boost in efficiency and productivity, no matter the industry.
So all of this leads to a pretty fundamental question. As these machines get smarter and show up in more places, what does our future living and working alongside them actually look like?
Well, what a lot of the experts are saying is that the real goal here isn't just about replacing people. It's about creating a true partnership, a kind of human-machine symbiosis, where you combine the best of both worlds to do things neither could do on their own.
And this part is absolutely critical. For this partnership to actually work, the technology has to be built for us, for people. This quote really nails it, especially when you're talking about assistive robots. You have to think about what people actually want and need. The tech has to serve us, right? Not the other way around.
And the cool thing is, we're already building the tools to make that connection happen. We're working on brain-machine interfaces that let people control advanced prosthetic limbs just by thinking. Surgeons are using augmented reality to see critical data right on top of their patient. And we're creating digital twins, perfect virtual copies of robots and workspaces, so we can simulate every little interaction to make sure they're perfectly safe for people to work with.
But for any of this to work, for this symbiosis to actually happen, we need one thing above all else: trust. And it's not just one thing. It's a whole package. It's not just about trusting the AI's decision. It's about knowing the entire system is solid, that the hardware won't fail, the software is secure, and that we can fundamentally trust the way it thinks. Which leaves us with the ultimate design challenge for the future. It's not just about building a body, senses, and a brain anymore. It's about designing that seamless, safe, and trustworthy partnership. And that's the question that engineers, designers, and really all of us are going to have to answer together. Thank you for watching.